Hi everyone, today I want to solve a question about max consecutive ones, uh, version 3. I already solved the first version. The second version is the same as this version, only the k is 1. So you can find the first version in the description. And the question is, given a binary array nums and an integer k, return the maximum number of consecutive ones in the array if you can flip at most k zeros. We have two examples here. The first example is an array which only has 0 and 1, and if we flip 2 0, we can see that the maximum one can be this one, which is 6. Let's go to more detail for the solution of this question. The best solution for this question is the sliding window approach. I already provided a video about a sliding video concept, and I will put the link in the description of this video. If you didn't see that video yet, you can go to see that video at first and then come back to see this solution. Here we have one example, and for this example k is 2, and we should return the maximum consecutive ones in our array if we can flip 2 0 to 1. And for this example, this is the answer. We can flip this 2 0, and then we have this, that is 6, or we can flip this 2 0 to 1, and then here we also have 6, and our output should be 6. This problem is one of those problems that can solve with a sliding window, and the size of the sliding window is changing during traversing the array, since it's totally dependent on the number of the zero that we are seeing during traversing the array. So at the first step, we set our left and right pointer, same as the previous question in the sliding window. We set our left to 0, our right to 0 at the first step. And since we want to find the maximum length of our 1, we set a parameter, a variable, to keep track of the maximum length of our array. So here, at the first step, the value at left and right is 0, and we can see that the length of the window that contain 1 is 1, and each time is calculated by right minus left plus 1. And at the first step, this maximum length is 0, and at each iteration we update the maximum length to the max of maximum length and this value. Or let me to put that in this way: at each iteration we compare this value with the maximum length, and if this value is greater than the maximum length, we update the maximum length. And in this figure, we show the left and right at the start and end of our window. So here we can see that our left is 0, right is 0, our window is from 0 to 0. And since we only have one maximum length, since we only have one in our window, we set the maximum length as 1. So how we should move our pointer in this problem? At each iteration, we can move our right pointer 1, but it's totally depend on the number of the 0 in our window. If the total number of the 0 in our window is greater than k, we have to move our left. Okay, so we have to consider another variable, and let's put a name for it as count, which shows the number of 0 in our window. At the first step is 0, and here, since our window does not have any 0, it's 0. Okay, then we move our right pointer to see the next value is 1 or 0. If it's 0, we add 1 to our count. If it's 1, we do not do anything, and then again we increase our right pointer. So we increase our right pointer, we can see that our window is here, and the maximum length right now is in the previous step it was 1. Here we have 2, so we update our maximum length, and our start and end of our window is 0 and 1, and here still the count is 0, since in our window we don't have any 0. So we move our right pointer to the next one. Then in our next window we have 3 1, we update the maximum length, still the count is 0, since we don't have any 0 here. And the left is still at index 0, since, as I said, when we see 0 and the number of the count is greater than k, we have to move left. If we don't have, we keep the left at the same position as before. And at this step, we can see our window is this, and we can flip this 0 to 1. It works like 1, and we have our count as 1 since we have 1 0 in our window. Okay, we have our count as 1, the maximum length is 4 since we can flip this value and it's same as 1, and our start and end of our window is 0 and 3. Then we move to the next index for the right pointer. Here is, and when we move here, our count is 2, our maximum length is 5. Since we have 5 1 here, we can convert this 2 0 to 1, and we know that our ka for this example is 2, and start and end of our window is 0 and 4, and maximum length is 5. Okay, but for the next iteration, when we increase our right pointer to here, the count is 3. Okay, since we have another 0 here, and we have to move our left pointer to right. So we move our left pointer here, we can see still our count is 3. We move our left pointer here, we can see still our count is 3, which is greater than 2. And then we move left here, still our count is 3, which is greater than 2. And then we move our left here, we know that our right is here, we know here we have 2 0, which is 2 equal to 2. So we keep the left here, our right is here. Okay, so the most important point here is that when we see a 0 and when our count is greater than k, we have to move our left pointer until the count is equal to k. So here the left is 0, the right is 0, and here our count is 2. Okay, at this point we can move our right to here, count is still 2. Then we move right here, count is still 2, here still 2, here still 2, and here our maximum is 6 since this can be 1. But when we move our right here, the count is 3 again. For this, count is 3. We have to move our left, and then we move our left here. We can see here, we move our right here, we move our right here, and still our count is 2. And then we move right here, still our count is 2, and the maximum length is 4. Sorry, the maximum length is 5. Since here we have 4 and we compare 4 with 5, we already have 5 here, and now we compare our 4 with 5 is less than that, and still our maximum length is 5. And then we move our right, and still our maximum length is 5. Then we move our right again, and still our maximum length before this point is 5. But here we compare our length, that is right minus left plus 1, which is 9 minus 4 plus 1, which is 6. 6 greater than 5. We update our maximum length, and then when we move our right pointer to here, we can see we have 3 0, and we have to move our left here. Okay, so last step, we move our right pointer here and our left pointer here, and our maximum length is 6. Okay, so here is the for the time and the space complexity. For the time, we only traverse the array one time, so the time complexity is O of n, which n is the length of the array. And for the space complexity is O of 1, since we only have some pointer here and we did not use any extra space for our solution. Go through the different window one more time. The explanation in the sliding window pattern, we set a pointer left as 0, we move our pointer right by a for loop or a while loop. Here I will use a for loop, and since we want to find the maximum length of the consecutive ones, I set a variable to keep track of the maximum ones. So let's set this as maximum length, and at the first step is 0. And since we want to count the 0 in our window, I set a variable count 0, and I set that to 0 at first. So right now we can move our right pointer to our array, and if the value at right pointer is 0, we add 1 to our count of 0. Okay, so if nums at right pointer is 0, we add 1 to our count 0, and then we check if the count 0 is greater than k, we have to move our left pointer. Okay, so we can use a while loop, since maybe at the first value in our sliding window are 1, so we have to move our left until the count 0 is equal or less than k. Okay, so we can say while count 0 is greater than k, we check if the value at pointer left is 0, we decrease the count 0 by 1, and we move our left pointer by 1. Okay, so here we check if nums at left pointer equal to 0, we decrease our count 0 by 1, and we increase our left pointer. And here we have one condition, since we cannot move our left pointer until the end of our array. We should check our left pointer should be less than or equal to right. So while left is less than or equal to the right, and our count 0 is greater than k. And at each time, the number of the 1 in our sliding window is right minus left plus 1. And since we want the maximum number of 1 in our sliding window, we can update the maximum length at each. We can update our maximum length of consecutive 1 by comparing the maximum length at each time with the right minus left plus 1. This is the number of 1 in each sliding window. And at each step, we compare it with maximum length, and if it's greater than the previous maximum length, we update the maximum length to this value. And then by end of that, we return the maximum length as the output. Okay, we can see that this works. And about the time and the space complexity, for the time complexity, since we only move one time through our array, our time complexity is O of n, which n is the length of the array. And for the space complexity, we didn't use any extra space here. We only have some pointer and a variable here. So for this reason, our space complexity is O of 1, since we did not use any extra space here. That's it. Thank you so much.